So this video is going to be about probability. Maybe you're here because you love probability, or because you really need some help with a test, or you just want to learn some more. Either way, this video is going to teach you about probability. So here we have our notation, which is important to learn before you actually start solving probability problems. Whenever you see A, it means event A. And whenever you see A with this apostrophe, it means A prime, or the complement of A, or everything that is not A. So if A is, well, A plus A prime always equals 1. So if A is 0.6, then your A prime is going to be 0.4, because if A is 0.6, then everything that A isn't is 0.4. Down here, we have A intersect B, and that is the intersection of events A and B. And then we have the union of A and B, which is the union of events A and B. And the intersection is A and B, and the union is A or B. To better show the intersection and union of A and B, I have drawn a Venn diagram. So for right here, A intersects B, that would be the overlap of the two circles. So that would be everything that's right in here. Everything that they both have, that they both share, the overlap right here. For the union of A and B, that is everything in these circles. That is all of that. Now for probability, it is important to know about independent events and dependent events. Independent events are events where one outcome is not affected by the other outcome, or the events are not affected by the other events. And dependent events are when they are, so one event will be affected by another. Now, for independent events, what we need to know is the formula for it. So the formula for independent events is the probability of A intersecting B equals probability of A times probability of B. That is the formula that we will need to know for independent events to solve the problems that are coming later. So next up we have conditional probability, and right here I have written out the equation for conditional probability. So with this equation, if you were given probability of A and probability of B given A, you would know that, say probability of A is 0.6 and probability of B given A was 0.2. You would know and multiply those, and that would equal 0.12. But what if you weren't given both of these numbers and instead you were given the intersection over here? You would have to figure out how to switch the equation around to work for that. So then you would have, if you move the equation around, probability of B given A equals probability of the intersection of A and B over probability of A. So using this one equation, you can solve for the intersection or B given A. So right here is a problem. We're given that the probability of the intersection of A and B equals 0.6, the probability of A equals 0.8, and they want us to find the probability of B given A. So we're going to go back and use the equation that we found, which was probability of B given A equals the probability of the intersection of A and B over the probability of A. And for that, we know the numbers, so we'll just plug them in. So probability of B given A equals 0.6 over 0.8. And using your calculator, 0.6 over 0.8 equals 0.75. This gives us a final answer of probability of B given A equals 0.75. So here is a different way to solve the problem, but it's still with the same numbers. So here we're not given the intersection, we're given B given A. So if you had these numbers instead of the last numbers, you would solve it by using the other equation we had, which was so here's the other equation, and now we know these numbers, so we're going to plug them in. 0.8 times 0.75, and then if you do that math, it equals 0.6. So now we have the probability of A intersects B equals 0.6. It's also a good way to check. So now here's a practice problem. So given probability of A intersects B is 0.28 and probability of B is 0.5, find probability of A given B. So go ahead, pause the video right here, solve this in your notes, and then resume the video to check your answer. Okay, so for this problem, we're going to once again start with the equation. You don't have to write it down if you know it, but I know for some people, and me included, it helps to write it down so you can see it. There's your equation. So now to solve for A given B, you're going to plug in your numbers. So 0.28 over 0.5. Doing the math, you should have gotten 0.56. So probability of A given B equals 0.56. That should be your final answer. You could go back and check that like we did before. Now plugging this and the probability of B in and seeing if you get the intersection of 0.28. Now next we'll be learning about combined events, and right here is the formula that we will be using for the next few problems with that. Now this formula could be used just as it is, or just like the other formula, like we switched around to solve for other different things. So we could take this right here and add it to this side. At the same time, take this right here, subtract it from this side. So this one we're adding, this one we're subtracting, which will then give us the equation of right here. So we can use either of these equations depending on the information that we are given to solve with. So right here is one of our practice problems. So the probability of A equals 3/11, the probability of B equals 4/11. So knowing that, calculate probability of the intersection of A and B if, now we have two parts here. First part is probability of the union of A and B equals 6/11. So that would be plugging that into the equation and solving it. And down here, our second part is for calculate probability of intersection of A and B if events A and B are independent. So that's going back to what we learned in notation, which I hope you wrote in your notes, was the independent formula, how to find whether or not they're independent. So we're going to be doing that. So write this problem down in your notes, and then I'll. So here's the problem. I kept the information at the top, and then I went and wrote out the equation for the combined events, and now we're going to plug in some numbers. So the union of A and B we know is 6/11. We know that probability of A is 3/11. Probability of B is 4/11, and we don't know the intersection of A and B yet. So just like we did before, we can switch this equation around to solve for the intersection. So we can add this to over here on the left side, and we can subtract 6/11, which will leave us with So we'll have the probability of the intersection of A and B equals 3/11 plus 4/11 minus 6/11, and that gives us 1/11. So intersection of A and B will be 1/11. So once again, I have our information written out at the top here, and I put our intersection that we solved for to be 1 over 11, because now for part B, we need to find whether or not these two events are independent or not. And for that, we're going to use the independent equation. So we wrote this down and talked about a little bit in the notation section. But you will know if two events are independent if their intersection equals the probability of event A times the probability of event B. So we know the intersection, we solve for it. 1 over 11 equals, now we have 3/11, jumping ahead here, times 4/11, and that gives us 12 over 121, and if we divide that out, we get 1/11 equals 1/11. So, did you catch the mistake here? These do not equal 1 over 11. If you turn them into decimals, this one is 1 over 11 equals 0.909, and 12 over 21 is 0.0991 to 3 sig figs. So these actually do not equal each other, which means that these events are not independent. So if you caught that mistake, good. Alrighty, so right here we have a practice problem, practicing combined events. So we have the probability of A equals 0.25, the probability of B equals 0.4, the probability of the union of A and B equals 0.55. Now this question has many different parts, so definitely pause the video and take some time. A is asking find the probability of the intersection of A and B. Part B is asking are A and B independent events, and part C is asking find the probability of A given B. So right here, pause the video, take as much time as you need, make sure you write this down in your notes, and solve it. Okay, so now that you've taken some time to solve the different parts of this problem, I'm going to start. I'll show you the answers. So part A is find the intersection of A and B, and to do that, we know that we use the equation. We use this equation right here, and we can plug in the information we know. And once again, we can add this part right here, the intersection of A and B, to the left and subtract 0.55 from the right. And this gives us an answer of 0.1. So the probability of the intersection of A and B is 0.1. That is the answer for part B. It's asking are A and B independent events, and for that we use the independent events formula. Right here, and then we can start plugging in some information. We know from part A that the intersection of A and B is 0.1. .25 times 0.4 is 0.1. So the answer is yes. these two events are independent because the equation equals. So for the last and final part of this problem, we were told to find the probability of A given B. We know that that can be written as just like that. And we also know the equation to find this. There's our equation. Now, as long as we know the equation, I'm going to erase it so I have some room to solve it. But using that equation, you just plug in numbers, which I'm sure you did. So the intersection of A and B we know was 0.1, and then the probability of B is 0.4, and 0.1 over 0.4 gives us 0.25. So the probability of A given B is 0.25. That is the answer for part C. So to recap, here are the answers for the second practice problem. Part A was the probability of the intersection of A and B equals 0.1. Part B was yes, that they were indeed independent. And part C was that the probability of A given B equals 0.25. So make sure that those are your answers. Check them. Well, I hope you learned about probability today. I hope you enjoyed the video, and thank you for watching.